All right, that's a dividing monomial, means one term in the numerator, one term in the denominator. And the relationship among the numbers and variables are just multiplication and division. Divide a polynomial by a monomial. Remember this, remember 3/4 can be written as 1 plus 2 over 4. We can split as 1 over 4, 2 over 4, and it's 1 over 4 plus half. Right? There's different ways of writing 3 over 4. So if we have this variable, we have a plus b divided by c, that can be written as a divided by c plus b divided by c. Right? As long as we have a common factor, we can add or subtract the numerators. So let's see. We want to simplify this expression. We have binomial in the numerator, we have monomial in the denominator. So by this, we have a plus b in the numerator, we can split into two, right? Two fractions. So we're going to do that. The 4x squared divided by 2x plus 6x divided by 2x. Or 4x squared divided by 2x, that's just 2x. 6x divided by 2x, that's 6 divided by 2, which is a 3. Okay, anyone has any questions? Well, this is showing another way, right? We see the numerator, 2x is a common factor, so we can factor out 2x. Then 4x squared becomes 2x, 6x becomes 3 inside the parentheses. Then we have 2x over 2x, that's 1. So 1 times 2x plus 3 is 2x plus 3. Well, similarly, this one was split into 2. 16 divided by -4, that's -4. C to the 8 divided by C to the 3, that's C to the 5. So I'm negative 4C raised by 5. The second term, 32, C to the 5th, divided by -4, C cubed. Well, 32 divided by -4, that's -8. Right? C to the 5th power divided by C to the 3rd power is C to the power 5 minus 3, which is 2. We have both negative sign. If we want, we can factor out to be the bottom one. But those two exactly the same. Anyone has any question? All right, we'll keep moving. Now we have a trinomial divided by a monomial. Right? So this is a trinomial, 3 terms, divided by a monomial. We can write this way, right? We can write trinomial over this monomial. We can write divided by 7c cubed b squared. So we just do each one. So in the trinomial 3 terms, we just divide the 7c cubed b squared for 3 terms individually. So -70 c to the 10th b to the 4th divided by 7c cubed b squared, what do we get? -70 divided by 7, that's -10. C to the 10th power divided by c cubed, that's a c to the 10 minus 3, which is 7 power. b to the 4th divided by b squared, which is just b squared. Then the second term, -56 c to the 5th b to the 5th divided by 7c cubed b squared. Well, that's -8 negative 56 divided by 7, that's negative 8. Then c to the 5th power divided by c to the cube is c to the 5 minus 3, which is c squared. Well, b to the 5th power divided by b squared, that's b cubed. Third term, negative 63, c to the 7th, b to the 6th, divided by 7c cubed b squared. Well, that's negative 9, c to the 7 minus 3, which is 4, b to the 6 minus 2, which is 4. Right. Or if we know how to factor them, right, we probably factor 7c cubed b squared. If we do that, we see the inside becomes negative 10, 7c to the 7b squared minus a c squared b cubed minus 9 c to the 4th b to the 4th. Anyone has any questions? If we can factor, if we know how to factor, you see this factor divided by this, those two are the same. So something divides itself equals 1. So we're left with the inside parentheses. And of course, this equals to the answer we're getting from another way. Okay, now maybe we divide a binomial, right? We have two methods. The method is called a synthetic or long division. So we're dividing a binomial, 6x minus 25. That's a binomial because it has two terms. So how do we divide? We make this sign, looks like a square root sign. Then we put the numerator. We put the numerator inside. We put the divisor outside. Let's go to the whiteboard. Let me go to the whiteboard to explain this. Let me first write this question. So 5x squared plus 7x plus 25 divided by 6x minus 25. So let's go to whiteboard. So 5x squared plus 7x plus 25. So this is divided by to make this sign. Okay, make this sign. Then divided by 6x minus 25. 6x minus 25. So make this sign. Looks like a square root sign. Right? So the dividend, the numerator, we put inside. The denominator or the divisor, we put outside. Now what do? We want to eliminate the terms inside from this direction. Okay, we want to eliminate 5x squared, then we want to eliminate 7x, then we want to eliminate 25. All right. So because this is a binomial, so we take two terms inside. 5x squared plus 7x. Right? So we want to match. We want to multiply something. Want to put on the top. Multiply 6x to get 5x squared. So which number? So this is a little bit. Yeah, this is a little bit more. So basically, we think. Actually, let me change the number a little bit. Let me change this 6 to be. Let me change this 6. Just x minus 25. Okay. Because the fraction is too difficult to deal with it. Just 1x. Just 1x. So what do? I want to put on the limit on top of 7x because I have to take two terms. On top of 7x, I want to put a 5x. Because 5x times this x, let me make this. Because 5x multiplied by x gives me 5x squared. Right, so I put 5x squared down here. Then 5x times negative 25, that's negative 125x. Okay, so what did I do? I was thinking why I put a 5x here. Because I want to get rid of this 5x squared. Right? So I'm thinking, okay, whom should I put over here? Multiply by x gives me 5x squared. That's 5x. Now 5x times x gives me 5x squared. I'm going to do subtraction. Right? So when I subtract, those two cancel each other. So I got rid of this. Then 7x minus negative 125x becomes positive 132x, right? So 7 plus 5 is 12, 132x. Then I take the next one down, next number down. Next number is 25. I take 25 down. I put over here, add 25. Right. Now I want to get rid of this 132x. How do I get 132x? I have to multiply 132 in the numerator. So I'm going to do plus 132. So the quotient now I have 5x, now plus 132. Because 132 times x gives me 132x. Then negative 25 times 132 is a big number. So I'm going to just be lazy, okay? Negative 25 times 132, whatever this is. But then I subtract again. I subtract with parentheses. So 132x subtract 132x gone, becomes 0. That's exactly why I put 132 here, because I want to eliminate from left to right. Now I have 25 minus negative 25 times 132. Minus negative becomes plus. So this becomes 25 times 133. We could use the calculator, okay? So what does this mean? This means 5x squared plus 7x plus 25 equals to x minus 25. Well, I could do two ways. Let me write it the first way, then I'll write it the second way. Divided by x minus 25 equals to 5x plus 132 plus plus a fraction. Plus a fraction. The numerator is 25 times 133. What's the denominator? Denominator is the divisor, x minus 25. So I can write this way, or this part can be read as a division, right? Or I can write this way. I can write 5x squared plus 7x plus 25 equals to x minus 25, the divisor, multiplied by the quotient, 5x plus 132, then plus the remainder. What's the remainder? 25 times 133. We could write this way. Okay, in this way, you see we have divisor. So this is the dividend, divisor, quotient, remainder. Right? So this is the divisor. This is the quotient. This is a remainder. So two ways to write this. All right, I hope you see the difference of writing this. Anyone has any question?
Can you do another example? Oh.
Yes, I'm gonna do another example. Before I forget, or maybe I'll talk to you later, okay, about your exam. Let's do another example. Let's do this one, 5x squared, or this is x minus 2, right? You see this one is exactly the same, 5x squared plus 7x plus 25 divided by x minus 2. So 5x squared plus 7x plus 25 is the dividend, the numerator. X minus 2 is a divisor, is the denominator. So when we do a long division, we would get a quotient 5x plus 17. But then we will have remainder 59. So we could write this way. We could write 5x plus 17 plus 59 divided by the divisor x minus 2. To show 59 is the remainder. Well, we can write this way. We can write the numerator or the dividend, 5x squared plus 7x plus 25, equals to the divisor, x minus 2, times the quotient, 5x plus 17, plus the remainder, 59. Okay, you see the difference? The first one has a divided by x minus 2, but the second one, just the dividend. Let's do this one. 3x cubed plus 4x squared. Let's go to the whiteboard. So this example, we have 3x cubed, 4x squared. 3x cubed plus 4x squared divided by x plus 1. divided by x plus 1. Okay, so we call this method long division. Long division. So the dividend, we put it inside this sign. This sign looks like a square root sign. It's long division sign. The numerator or the dividend, we put it inside. The divisor or the denominator, we put it outside. Well, again, we're going to eliminate. We're going to eliminate from left to right, going this direction. Okay, we're going to eliminate term by term. In the end, when the degree of the polynomial is lower than linear, basically if it's a number, we know we are done. We're done division. Like last example, right? The divisor is linear, then the remainder is a constant, is a number. So we know we cannot go further. Now we want to match up with 3x cubed. So what do we need for the quotient? We need a 3x squared, right? Because 3x squared times x give us a 3x cubed. Oh, Ajay, you cannot hear anything? Anybody else has a problem to hear me? The volume, my voice volume is up. Oh, no? Oh, really? You cannot hear me? Oh, what's going on? Let me log back on then. Oh, you guys cannot hear me? Oh, they can hear. Okay. Oh, you can hear me. All right. It's not. Oh, you don't have a problem to hear me. All right. Okay, Ajay. I don't know what to do with Ajay. If you cannot hear me, log out, then log back on. All right. But she cannot hear me. Oh, I don't know what to do. Let me tap to her. Let me tap to Ajay. Yeah, Ajay, any question?
Professor, can you hear me?
Yeah, I can hear you.
Quick question, just to clarify, when you have a division equation like this, can you not arrange it so that it would be 3x to the third plus 4x to the second over x plus 1? Or does it have to have the...
When we do long division, we have to put this way.
Understood. Okay, thank you.
You're welcome. Let me tap to Ajay. How do I tap to Ajay? How do I do it? I'll send a chat message. Okay. We try to log out, then log back in. Others can hear me. All right. Okay, so when we do 3x cubed plus 4x squared, right? We can write this. When we write the division, we can write this like over x plus 1. X plus 1, right? No problem. Or we can write the polynomial 3x cubed plus 4x squared divided by, open parentheses, x plus 1, close parentheses. Okay, but when we do long division, that's the only way. When we do long division, we have to, I just still here. She cannot hear me and she cannot see it. I don't know what to do. When we do long division, we have to make this sign. This sign looks like a square root sign. We have to make this sign. We put the numerator or the dividend inside, the denominator or the divisor outside this sign. Then what do? We're trying to eliminate term by term from left to right. Okay, so my first goal is to get rid of 3x cubed. How do I get 3x cubed? So I'm going to make this x multiply by something in the quotient. The top is the quotient part, right? To be exactly 3x cubed. To be 3x cubed. That's my goal. Because why? Because I want to subtract. So I'm going to subtract. When I subtract, the two same things become 0. That's how I eliminate. So the quotient, the members in the quotient multiplied by the leading term in the divisor, which is x, has to match with this. So that's why I have to put the 3x squared. I have no other choice. Right. Now I have to multiply 3x squared with 1. Well, if I multiply those two, that just is the same thing. Right. Just add 3x squared. So 3x squared here in the quotient has to be multiplied with the x. We get 3x cubed. Has to multiply by 1. But then we get 3x squared. Then we subtract. We subtract those two from these two. So 3x cubed minus 3x cubed is 0. That's how we manipulate it to get it. Now we have to do 4x squared minus 3x squared, which is just 1x squared. Is 1x squared, right? Then normal term. Here we only have 2 terms, right? We only have 2 terms. Then we have to think to add something. So how do we match up from x to x squared, which is plus x? Plus x, right? Because x times x is x squared. So x times x is x squared. Then we have to multiply x with this 1. X times 1 is just x. You see here we only have x squared. Well, we could think this is 0, right? We could add a 0 here. So minus, you see x squared minus x squared is gone. So we eliminate it. 0 minus x, that's negative x. Right? Negative x. Well, negative x, there's no more term, we just plug 0 here. So take a space. Then in the numerator, what do we put? We put a negative 1. Because negative 1 times x will be negative x. Then negative 1 times positive 1, negative 1. Negative x minus negative x again becomes 0. 0 minus negative x. 0 minus negative become positive. So that just equals to, oops. It just equals to positive 1. Any questions for this one? This step is called a long division. So the goal is you put the dividend or the numerator inside this sign, the divisor, or the denominator outside the sign. Then you try whatever you put in the quotient, you're getting rid of the leading coefficient from left to right. until you reach, because the divisor is linear, so the remainder has to be 1 degree lower than the divisor. The divisor is linear, the remainder has to be constant, has to be a number. Anyone has any question? Okay, let's go back to our notes. So basically, we have to know those words: divisor, dividend. Dividend is the numerator. Divisor is the denominator. Quotient. Quotient is the dividend divided by divisor, the even parts. Then remainder is 1 degree lower than the divisor. Right? But this one is not finished. So this one actually should be, let me change this. Three x squared plus x minus 1. 3x squared plus 4, 3x squared plus, oops, forgot already. 3x squared plus x minus 1. Three x squared plus x minus 1. Then the remainder is 1. Remainder is 1 degree lower than the divisor. 1 degree lower than the divisor. Anyone has any question? I heard. Okay, anyone has any questions? I heard a sound. So the remainder has to be 1 degree lower than the divisor, okay? Well, let's see this one. We have 6x squared plus 7x minus 21 divided by 2x plus 5. I want to change this one to be like this, looks like this. So we do the calculation, we get, oops. What did I do? Because I want to change it to be nice writing, but anyway. So for this one, if we do the calculation, we get 3x minus 4. Maybe I'll put parentheses around. So this is the quotient. But what's the remainder? Remainder is a -1. If I rewrite it another way, I can write this way. I can write equals to divisor 2x plus 5 times 3x minus 4 minus 1. Okay, that's another way of writing it. Oh, you're right, because I did not change it. I did not change it. Thank you. Thank you. So let's see this example. This example is 6x squared plus 7x minus 21, the dividend or the numerator, divided by a linear polynomial, which is 2x plus 5, which is the divisor or the denominator. If we do that, we get the quotient to be 3x minus 4. 3x minus 4. Then the remainder is -1. So we can write in two ways. We can write 6x squared plus 7x minus 21 equals the divisor multiplied by the quotient, subtract or add the remainder. Anyone has any question? The next example is x cubed plus 2x minus 3 divided by x plus 2. And this one, we see we don't have x squared term. We have x cubed, x raised by 1. We don't have square term. So when we put it inside the long division sign, we got to keep O, write this, plus 0x squared to take the spot. All right, I hope this makes sense to you. Actually, let's do it in the let's do it on the whiteboard. So we have x cubed plus 2x minus 3 divided by x minus 2. So when we do long division, I always press the wrong button. So type in the dividend first, which is an x cubed. We don't have square term, so what I'm going to do, we're going to put 0 x squared term. Then plus 2x minus 3 then make this sign like a square root sign. Then put the divisor outside. What's the divisor? X plus 2. X plus 2. Outside this sign. Now we want to put on the quotient. So the top part on top of this sign, we write down the quotient. So we need x squared in the quotient, because x squared times x will be x cubed. Right. So put here x squared on top. The top part is for quotient, because x times x squared, that would be x cubed. Then we have to multiply x squared with 2. So plus 2x squared. Then we subtract. So that's how we get rid of x cubed, right? X cubed minus x cubed becomes 0. Now 0 minus 2x squared, that's -2. That's -2x squared. Then plus 2x. Right? But each time, because we're dividing by a binomial, so each time we just take 2 terms. Now what do we need on top? We need to put a -2x on top, right? negative 2x on top. Because x times negative 2x will give us negative 2x squared. Negative 2x squared. Then negative 2x times 2, because I have to multiply negative 2x with 2, that's negative 4x. So I have to multiply with this, and also I have to multiply this with both of them. All right. So I get two terms. So now again I do subtraction. Subtract. So when I subtract, the first term gets eliminated. 2x minus negative 4x, that's positive 6x. Then I take next number down. Next number in the dividend is minus 3. Now clearly I see in the quotient, I need to put down plus 6, right? Plus 6. Because 6 times x gives me 6x. 6 times 2 gives me 12. So I get a 6x plus 12. I subtract again. Every step is a subtraction. That's how we get rid of the leading term. Right? This leading term is gone. Or negative 3 minus 12. That's minus 15, right? And that's it. So now we finished. We don't have to go further. Why? Because negative 15 is a number, is 1 degree lower than the linear. If the divisor is a square, so as long as here is linear, we stop. So this one, see, the quotient is x squared minus 2x plus 6, and the remainder is negative 15. Anyone has any question?
You said that the remainder has to be lower than the what?
Okay, the remainder has to be 1 degree lower. Has to be 1 degree lower than the divisor. In this case, the divisor, let me circle the divisor. You see the divisor is linear, x plus 2 is polynomial of degree 1. So the remainder is polynomial degree 0. Does that answer your question?
Thank you.
You're welcome. Any other questions? Okay, let's go back to our text, to our notes, So same thing for this. You see this one missing square term, missing x term. What do? We just add a 0 to take the spot, right? And this one, if we do, there's no remainder. Remainder is 0. Or don't see no remainder. So remainder is 0. Right. So what does this mean? This means the dividend can be factored. Oh, it comes down here. Right. Let's look at this. You see, this is oh no. So that means x cubed minus 64 equals to the divisor multiplied by the quotient. No remainder. Well, remainder is 0. If the remainder is 0, that means the dividend, the numerator, can be factored as a factor of the divisor and the quotient. So this is just another example, all right? Also divided by binomial. This one has remainder. Okay, that's dividing by polynomials, but we have polynomial functions, right? Polynomial functions means only one variable, and we can divide the polynomial functions also. You have two functions, f divided by g, right? Or can be written this way or can be written this way. And we require function g not 0, because we don't divide anything by 0. Let's see this case. F is defined as polynomial degree 3. G is defined as a linear. So we want to find f divided by g. Okay, we have this formula. Dividend equals the quotient times the divisor plus the remainder. Okay, a function can be written as x minus c as a divisor. Quotient, we use q of x to represent, and the remainder. Okay, remainder is always 1 degree lower. So in this case, what's the divisor? Divisor is linear, so r has to be a number. So I have two theorems. Okay, one theorem is called remainder theorem. If a function can be written as this, quotient multiplied by the linear divisor plus a remainder, then f of c, look at this, c evaluated at c, will be equaling to that, will be equaling to the remainder. Why? Because c minus c is 0. Okay, so this is called remainder theorem. And you will have questions like this. Okay, a function is written as a quotient times divisor plus some remainder. Then ask you to evaluate c. So I'm going to change this color actually to make it obvious. How do I do this? It's not easy to see. You see this c? This is x minus c, right? And we want to evaluate f of c. What happens? C minus c is 0. 0 times anything will be 0. So it's just a remainder left. That's why f of c equals to the remainder. Any question? Let's see an example. So f is a polynomial degree 3 because x cubed plus 2x minus 3. Now we can factor this as, we want to find f of negative 2. Okay, so let's put this one on top. Using remainder theorem to find f of negative 2. Right, so that's our goal. Remainder. We're using remainder theorem to find f of negative 2. So what do? We want to put this one factor. So what is the divisor? The divisor will be x minus negative 2, which is x plus 2. Right. So we want to do long division with this, with divisor x plus 2. Then when we do that, we get a quotient to be x squared minus 2x plus 6, and the remainder negative 15. So if we want to evaluate f of negative 12, that just equals the remainder negative 15. Because here x minus x plus becomes, right? X is negative 2 plus 2 is 0. 0 times the quotient will be 0. So only the remainder left. So that's a remainder theorem. Anyone has any question? Okay, let's see this one. Use remainder theorem to find f of 5. Right. So what do? We do long division. Oh, this one is already done. So we have divisor x minus 5. We have the quotient x squared plus x plus 9. Well, then f of 5, this guy, just 31 by remainder theorem. Right, just 31. So we have these formulas. A cubed minus b cubed equals a minus b times a squared plus ab plus b squared. A cubed plus b cubed equals a plus b times a squared minus ab plus b squared. Difference of two squares, right? A plus b, a minus b. Perfect square, square the first one, square the second one. Multiply the first one and second one and double it. Right? Similarly for a minus b. A minus b squared equals a squared minus 2ab plus b squared. Oh, just left. So x cubed minus 1 can be factored, according to the top, can be factored as x minus 1 times x squared plus x plus 1. So we see x minus 1 and x squared plus x plus 1 are factors of x cubed minus 1. Because you see this one multiplied by trinomial, right? One binomial times one trinomial. And those two are the factors of x cubed minus 1. Thinking 15 equals to 3 times 5. So we see 3 and 5 are factors of 15, right? But if it's 17, 17 equals 3 times 5 plus 2. So 3 and 5 are not factors of 15. Because the remainder is not 0, the remainder is 2. X cubed minus 1 divided by x squared divided by x minus 2, if we do a long division, we get a quotient part, we get the remainder part. So because we have this remainder, so we know x minus 2 is not a factor of x cubed minus 1. What is the factor of the number? For example, what are the factors of 10? So 3 is not a factor of 10, right? But 2, 5, 1, 10 are factors of 10. You see, let's see this example. We have x squared minus 3x. This one can be factored as x times x minus 3. So this one has two factors, x and x minus 3. And of course, 1 is a factor and itself is a factor, right? So if we think about x squared minus 3x divided by x, what is the remainder? And we will have x minus 3 in the quotient. So the remainder is 0. What is x squared minus 3x divided by x minus 3? What's the remainder? Well, we see x, it can be factored out of x, right? If we factor out x, we get x times x minus 3. X minus 3 divided by x minus 3 becomes 1. So it just equals to x, right? So the quotient equals to x. There's no remainder, or the remainder is 0. So if we could, we would like to write a polynomial function in the terms of factors, in their factor forms. Let's see this one. We want to be able to write f of x equals x minus c times quotient q of x. Because we like function to be factored form. In this case, you see x minus c, right? So c is a factor. X minus c is a factor. Then what is f of c? According to remainder theorem, f of c equals to the remainder, right? And in this case, the remainder is 0. So f of c equals to 0. And of course, you will plug in, we also get 0. So your homework, you have determine if a linear binomial is a factor of a given function, right? We don't want to complete the division, and we want to use the factor theorem. So if we do that, if we do long division for this, we use the dividend divided by x minus 2, and the remainder is 0, which means we're able to write this one in a factor form of x minus 2 times the rest, times the quotient. You still see the whiteboard? I see the notes. Anyone else still see the whiteboard? No. This is Angeline. Angeline, maybe fresh your page. Fresh your page sometime. Yeah. Yeah, we are in a new era of education, and it brings us a convenience. Also requires a good internet connection. Requires computer. Or random also see the whiteboard. Let me fresh mine. Let me change. Yeah, some of you see the notes, some of you see the whiteboard. Let me do one more time. What about now? What about now? Anyone still see the whiteboard? Oh, okay, that's good, great. All right, so okay. So okay, now everyone sees the notes. So let's see this question. This question, we have this polynomial of degree 7, right? And we want to determine if x minus 2 is a factor of this function, and without completing division, and using the factor theorem. So the factor theorem says, if x minus 2 is a factor, then f of 2 is 0, right? So we just evaluate to see if f of 2 is 0. So let's do here. So f of 2 equals to 2 raised by 7 minus 2 times 2 raised by 6 minus 3 times 2 raised by 5 plus 6 times 2 raised by 4 plus 5 times 2 raised by 3 minus 13 times 2 square plus 13 times 2 minus 14. Let's see if we get 0. So these two terms cancel each other, right? You see negative 2 times 2 to the 6, also 2 to the 7. So 2 to the 7 minus 2 to the 7, that's 0. So those two terms are gone. Then this will have negative 3 times 2 raised by 5. 6 we can write as 2 times 3. Right? 2 raised by 4. Then do you see this is also 2 raised by 5? Right? So those two cancel each other. Negative 3 times 2 raised by 5 plus 3 times 2 raised by 5. Those two canceled. Now this is 2 raised by 3. 2 raised by, so we're left with 5 times 2 raised by 3, that's 8. Minus 13 times 2 squared is 4. Plus 13 times 2, which is 26. Minus 14. Okay. So 5 times 8, 40. Negative 13 times 4, negative 52. Right. So 40 minus 52, negative 12. Plus 26, minus 14. Bingo, exactly 0. Because negative 12, negative 14, add those two, that's negative 26. So positive 26 minus 26, that's 0. So by factor theorem says if x minus 2 is a factor, then f of 2 is 0 indeed. All right. If it's not a factor, we will get a remainder, non-zero remainder. Right? If it's a factor, the remainder is 0. So that's how we determine if a given one is a factor or not. Well, let's say B. B says, okay, determine if x plus 1 is a factor. Well, we just, x plus 1 means x minus negative 1, right? We have to evaluate f of negative 1. When we evaluate, it's not 0. So it's not 0, that means x plus 1 won't be a factor of this function. Okay, so that's for today. And so what do we learn? We learn the dividing polynomials or dividing polynomial functions. We learn the two theorems. One theorem is called the factor theorem. One theorem is called a remainder theorem. Remainder theorem is saying if the divisor is x minus c, then f of c is a remainder of the function divided by the divisor. Factor theorem is saying, we want to say if it's a factor theorem is saying if x minus c is a factor, then f of c equals to 0. Okay, anyone has any question?
Hello?
Yes.
I have a question. It's about the exam that we just took. My grade still says NA, and I don't know, I emailed you about it like 2 days ago, and I was just wondering, like, if I never had another tab open, like, how can I cancel my grade?
Right, you still exam is not available, right? The grades is not
Yeah.
available,
Yes.
right?
Yeah, it says NA. I'm sorry?
Because it's not open to students yet.
So,
The coordinator is waiting for everybody. So some of the students haven't taken the exams yet.
okay.
Yes, so he's waiting for a couple of days to open for everyone to see it.
Okay, so the reason I can't see my grade isn't because, like, I'm being investigated or anything. It's just because everyone can't see their grade. Because some
Oh,
people...
he still does that. He asked the instructors to do that. I haven't been doing yet, but he's saying he's going to do it. So
Okay, so this is like normal, basically. Like, I shouldn't be able to see my grade.
yeah, if you haven't done anything, he has nothing to see about it.
Yeah, I
actually, I need to see something for how. Oh, let me see. How? Yeah, because last class I used his as example. I thought he checked other website. No, he did not. He checked other website is for some homework, not for
don't.
exam.
Okay.
Yeah, I guess our class did very well. Probably everyone. If you have, because they ask you to sign your name, right? To
Yeah,
write or not.
yeah,
Probably no one does that. So
yeah.
don't worry about that. Like if you haven't done anything,
Okay,
don't worry about it.
okay, okay.
I
Thank
didn't
you.
even know this. I thought it's not there because I don't know. I just
Okay,
got to know this point.
okay.
Okay.
I was just a little, I got nervous because I was like, I thought like I was being investigated because they thought I had another
Oh,
account open or
so the
something.
grades is not showing? No, no, no,
Yeah.
it's not. No,
Okay,
no.
okay.
I'm
Thank you so
sorry.
much. It's okay.
You're welcome.
All right.
Okay.
Bye.
Okay, bye. Yeah, the grades is not up yet, and yeah. Okay. Anyone else has any questions? So two theorems. All right, long division. So we learned the long division, and then we learned those two theorems today. All right, if you have no questions, you can just go ahead to start to do your homework. If you have questions, I'm here. And also, David, have you taken your exam yet?
Hello? I'm sorry.
Have you taken the exam yet? You need to take as soon as possible.
Yes, I'm going to take it.
Okay. All right.
Sorry
And
about
also your homework. Do homework also.
that. I will.
All right.
Thank you.
You're welcome. I think you're the only one. And Ajay is a special student. Submission for the exam. Right. Mario. Let me see. Sharabai. Let me check for you, Mario Sharabai. Mario Sharabai. Let's see. Yeah. Yes, you're fine. You're fine. You're also almost 88. All right. Oh, you're welcome. You're welcome. Let me stop recording.